Produced by neurons, they are communication tools. They send signals to other neurons, muscles, or glands.
As always, thank you to Neural Academy and to the Creepy Brain for kicking this week's podcast off. Hi, I'm Sydney, and welcome back to the amazing Astrocyte articles. Today I have Abby, Sam, Kirsten, and Valerie, who are all incredibly knowledgeable in the realm of a really special neurotransmitter that doesn't get enough attention. Today, it'll get the chance to be in the spotlight. So Kirsten, what do you think about our neurotransmitter glutamate? Give us a little introduction about the star of our show today.
All right, well, we all know that a neurotransmitter is a messenger that transmits signals from one neuron to another. These signals essentially control all of our body's functions. Now, let's talk about glutamate. Well, first of all, it's the main neurotransmitter in the CNS, and it's involved in many functions.
Just a reminder from last week's episode, the CNS, or the central nervous system, in the body consists of the brain and the spinal cord. Within the nervous system, there are many types of neurotransmitters that have their own jobs in assisting the body to function.
Glutamate is an amino acid that also acts as a neurotransmitter in the brain. It's considered a classical neurotransmitter and also an excitatory neurotransmitter. This means when a glutamate interacts with the receptors of a neuron, it's more likely to cause an action potential.
That brings me to my next question, Valerie. What makes glutamate different? We know a lot about neurotransmitters like serotonin or dopamine. So how is glutamate different from more well-known transmitters?
Well, thanks for asking. We know that serotonin and dopamine are essential for balancing mood. There are also neurotransmitters like adrenaline and noradrenaline that have an effect on the fight or flight system within our central nervous system. The neurotransmitter we will be discussing today is glutamate. Although glutamate does not have the same effects on the central nervous system as other neurotransmitters like serotonin, dopamine, or noradrenaline, it still has some pretty major impacts on the way our brain functions that are just beginning to be discovered.
Oh, that's so cool. Abby, can you tell us what kind of impacts does glutamate have on people's lives? Is it a common thing to have issues with, or is it something that isn't quite as well known?
It's funny because although glutamate itself isn't as popular in the public eye, it actually has a lot of implications in conditions that are pretty well known. So the main issue we see is excitotoxicity, which is basically just a fancy word for glutamate levels becoming too high, which causes way too much stimulation in the brain cells. So for example, in things like Alzheimer's disease or Fragile X syndrome, when there's too much stimulation of a glutamate receptor, or where the cell receives glutamate, it can lead to a funky imbalance in substances within the cell, which can then cause dysfunction or even cell death. On the other hand, something we see in stroke survivors is that glutamate helps modulate their deficits, and we can see abnormal glutamate levels and behaviors in the brain for up to 28 days post-injury. So to pull it all together, glutamate actually has some big, varying effects on conditions that most people have some sort of experience with.
Thanks for sharing. So Sam, putting everything we talked about together, what are some ways professionals can use this knowledge of glutamate to improve things like medical treatment or therapy?
Glutamate can be involved in clinical practice because we assume the physiological role of glutamate neurotransmission extends to the regulation of language access, comprehension, and production. In addition, disorders in glutamatergic transmission contribute to the pathogenesis of neurodegenerative and sporadic onset language disorders such as aphasic stroke symptoms and ataxia syndrome. So, we can actually use this in our clinical practice by understanding the root of the problem, which can impact and maximize treatment for these syndromes. This knowledge could also provide new treatments where we regulate neurotransmitters in the brain from an outside source and potentially help people with these disorders. So, glutamate regulating drugs like memantine may improve the outcome of language disorders.
Well, my friends, I'm afraid that's all the time we have for today. Thank you again to our talented glutonomists for joining us, and also a big thank you to the Ion Channel for continuing to support and run our podcast. See you next time. Play us out, Creepy Brain.
Excitatory, inhibitory, modulatory commands. While signals passing within your neurons are electrical.